the while and while statement does, just to recap, is that it will continue to execute a given block of code until a given condition is no longer true. In this case, user response is kind of the key that we're using here to determine whether we should continue running through this block of code or not. All right, so again, a very simple example. What I'm going to do is actually select this entire block, comment this out. It's not a very practical example, so I want to give you something much more interesting to work with. And so for this next example, we're going to create a menu system like you might have seen if you ran DOS programs way back like 25, 30 years ago. Okay, so here we're going to go ahead and start typing. I'll pause the video and then you can catch up. Once I finish typing in, you'll want to pause the video, type in some of the code yourself. Okay. All right. So you can see here that, and again, please pause the video. I'll give you an opportunity to type in all of the code. I'll give you a nice clean screen like this. Pause right now because we want to start by writing this code to display a menu. So we're doing something similar here with the user response. We're just going to call it display menu this time as a Boolean. We're setting equal true, and while display menu continues to be true, then we'll continue iterating through. Now, you can see here that I did not have like an equals true. That's kind of redundant. You don't need to do that because display value, or display menu rather, is already a Boolean. It's going to be true or false. So all we need to do is just check whether the expression, in this case, it's just a variable, equals true or false. Well, display menu already equals true, or it's going to equal false by its very nature because it's a Boolean. So you don't have to do the equals true or equals false part whenever you're evaluating a Boolean. Okay, so here's what we're doing. We're actually calling this other function called main menu, and then main menu will return back to us a Boolean, and then we'll decide whether to rerun the main menu based on the response that we get from main menu. So the real work goes on in this function main menu is Boolean. Here I'm going to clear out the console calling the clear method. All right, so that's a new method in the console. Here we'll just wipe out everything that was currently being displayed on screen. Then we're going to say, would you like to either play the print numbers game, the guessing game, or would you like to exit out of the menu system? Here we're going to retrieve the result from the user. What would you like to do, 1, 2, or 3? And here's where we then decide what are we going to actually do. Are we going to call into another method called print numbers because they want to play the print numbers game, or are we going to call into the guessing game method, and I'll show you those in just a moment because they selected number 2, or do you want to return false? All right, so in these cases, these methods will return a true or false. Here, when they want to exit, will return false. That'll get bubbled up through main menu into our main, and display menu will be set to false, so we'll break out and end the program at that point. Okay, so if they type in anything else, then we'll return true, which will return back to here, which will then set display menu back to true, which means we're going to call main menu again. We'll clear out and then say, all right, well, you didn't give us 1, 2, or 3, so I'm going to give you another chance to answer the question. And if you ever get confused about the flow of this application, just set a breakpoint and step your way through it using the debugging tools, right? So you can see how this actually works. Now, inside of the print numbers and the guessing game, for now, all I did was just implement console.writeLine. We're going to come back and flesh this out. So I've just stubbed out this method for the moment. But in both cases, we're going to return true, saying, okay, we finished the guessing game, or we finished the print numbers game. Why don't you just go ahead and re-show this menu to the user so they can decide what else they want to do inside of our application. So the nice thing about this little setup, and you can use this same little scheme that I've cooked up here to create multiple menu levels inside of a DOS-based, or rather a console-based application, okay? We'll flesh out these to show some more features of the while statement, and then also we'll look at that do, or the do while loop as well. Let's run the application and see how it works. So the first time through, we see there's a choose an option 1, 2, or 3. I'm going to choose number 1. And even though, unfortunately, you see that nothing really happened, the reason is because I forgot one line of code in both of these. console.readline, because we want to be able to show that text before we continue on. Okay. Here we go. Let's do it again. Print numbers game here. I'll press number 2. The guessing game here. I press number 3, and it exits. All right. So that's how the menu system works. Now let's focus on another aspect of this print numbers method and the guessing game to look at 2 different coding examples revolving around the loops, the do while and the while loop. Okay, so I'm going to pause the video again here as I type in some more code. All right, so I went ahead and fleshed out the print numbers method. You can pause it and catch up here. And then I also created this guessing game method. You can see most of it on screen right now. Pause it right here if you want to catch up. And then you can pause to see this end part in lines 82, 83, 84. So like I said, a lot of typing, but you'll definitely want to catch up with me and type all this in. Let me explain a few things about how this works. So the print numbers game, let's just go ahead and run the game and see how it works. Let's choose number 1 and we can type a number. I'm going to choose the number 7, hit enter, and you can see all it does is just prints out from 1 to 7. And that's pretty simple, right? Then let's play the guessing game. It's a little bit more involved. And we get to guess a number between 1 and 10. This is where things start to get a little bit more interesting. I'll guess number 3. That was the wrong answer. Number 4. Number 2. Number 6. 7. 8. 9. What did I miss? 5? All right, it took me 9 guesses. All right, so we randomly choose a number from 1 to 10. It's pretty cool. And then we keep asking, what do you want to guess the number? We could improve this, and maybe that's a good exercise for you to say you're getting warmer or you're getting colder or it's higher or it's lower. Maybe give some hints as well. But now we can exit out of the game. So the print numbers game, recall, it was fairly simple. All we're doing here is just allowing the user to type in a number, and then we're going to actually read that number from the readline method. And notice that I've got this little cint. We're converting readline because it returns to us a string value, as you can see over there on the right-hand side. But what we need to work with is an integer value. And the bucket sizes are different, so we're going to need to convert from the string, which if they type in the letter, the alphanumeric character 7, we need to convert that into the integer value of 7. Those are 2 different things, all right? So now that we have an integer, we can work with it in a mathematical sort of way, adding numbers to it and so on. As long as it's a string 7, if we were to attempt to add 1 to it, we'd probably get 7, 1 instead of 8, okay? At any rate, we create a counter just to keep track of how many times we're actually iterating through, and we're going to continue to iterate through until we get to the same result value that the user typed in, at which point then we'll pop out of our looping statement and continue on. All right, so for each number from 0 to, or as long as we're continue to be less than the value that was typed in, we'll continue to iterate through, but when this is no longer true, then we'll pop out of the iteration statement, okay? All right, so let's move on and look at the guessing game now. In the guessing game, you type in a number, and we are going to try and guess the number that the computer has selected. How do we get a number that the computer selects? We're going to use this class called Random. Random is a class created by Microsoft. Now, it's similar to the console class in so much that it's part of this library of code that Microsoft's allowed us to use inside of our applications, and it specializes in creating random numbers. But the way that we're using it is a little bit different. Like in this case, notice that all we had to do is just say console class.clear, console class.writeLine. Whereas in this case, we have to do something a little bit special. We have to create a new instance of the random class. And so we're creating a compartment in the computer's memory, a bucket in the computer's memory sufficiently large enough to hold this random data type. All right, and so we're going to call that bucket in the computer's memory random, lowercase r random. All right, so It's a little bit different than in the usage, and I'll explain the reason why, the different usage, in an upcoming lesson when we talk about classes. All right. But at any rate, so now that we have an instance of the random class, we can use the random class's methods. In this case, we're going to use the next method to grab a number between 1 and 10. So we give it what's called the lower boundary. So I want a number that starts anywhere from 1, but I don't want you to go to 11. So that's the upper boundary. Don't go to 11, 12, 13. Stop at 10. So it's going to pick a random number from 1 to 10 and store that number here. We're also going to keep track of the number of guesses for the user. So if it took them 5, 6, 7 guesses, whatever the case might be. And then we're also going to create this incorrect Boolean flag, because I'm going to anticipate that the user will be incorrect a number of times. And this will be what ultimately breaks us out of the do while loop and say, you were correct. It only took you 12 guesses, okay? And then we'll actually show the number of guesses on screen. Now, what happens inside of this code block is important. Notice that we're not using the while statement, we're using that do while loop that I alluded to a moment ago. And remember, the quality of the do while loop is that it guarantees we're gonna run this code at least one time. So in this case, I need to at least one time make sure that the user can see that they can choose a number between 1 and 10. And then every subsequent time, I'm gonna ask them again, all right, you were wrong, which is pick a number between 1 and 10. You were wrong, pick a number between 1 and 10. So I needed that inside of the code block, inside of my loop, and I needed to run it at least once. That's why do while loop made sense in this example, okay? Now, we're going to retrieve the guess from the user, and then we're going to increment the counter of guesses. Now, I could have done something like this, like I did previously, guesses equals guesses plus 1, but I chose to use a little shortcut, which is the plus equal. And so those two lines of code are equivalent. I just had to type fewer characters. So take the variable guesses and add 1 to it is essentially what line number 74 says. All right, next up, we're going to take a look here at the little check that we do. Now, we're going to grab the random number from the user. And this is the important part. Notice that random number is an integer, but I'm going to convert it to a string by calling the toString method. I could have done something like we did earlier with cstr, like that, and that would work just as well. So I'm going to convert this value to an integer. I'm going to convert this value to a string. I'll just go ahead and leave it like this. So we're converting data types. So this is an integer, but I need it to be a string so that I can compare it to the result. I just did the same basic thing 2 different ways here in these 2 different methods. But it's essentially the same kind of check. If the guess is incorrect, then incorrect will equal, or I'm sorry, if the result is equal to the random number. So if they guess the correct number, then it's no longer incorrect. It'll be correct. So we're going to set incorrect equals to false, which will then break us out of the loop. However, if they are in fact incorrect, incorrect will stay true, and we'll just say, hey, you're wrong, try it again, and we'll loop through this block of code another time. But assuming that they got it correct, we bust out, and then we just merely print this to screen, and then we return true in order to get back to our menuing system and allow somebody, the user, to choose a new game. All right. So hopefully you learned quite a bit in this lesson. We looked at a simple use case where we're just using the while statement in order to evaluate something and decide whether we should continue to iterate through the block of code based on something that happens inside of the block of code. We looked at how to create a menuing system using the while loop. And then we also looked at using the while loop in some creative ways in a more practical example here. And then we looked at using the do while just to compare the while versus the do while. The only difference is running the block of code a guaranteed time, at least once, versus not running it potentially one time. And then we also looked at a few other things like converting types using the cstr, so convert to string and convert to int method. We also looked at using the plus equal operator. So we also looked at the random class and how we're able to generate a random number. Now we can create some interesting little games. All right, so hopefully that was a pretty helpful lesson. A lot of typing, but again, that's good for you, creating muscle memory. New observations come whenever you're typing the code in yourself as opposed to just watching somebody else do it. So make sure you're getting your hands dirty in the code. All right, we'll continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, many types of applications that you'll wind up writing involve text, whether it's text that you'll need to feed into other applications, or text that you'll retrieve from end users, or text that you will actually format for display to an end user. So there's this notion of massaging data, changing it in subtle ways in order to format it specifically for input to another software system. Professional software developers spend a lot of time taking data, changing it in some way, and then putting it into another format for ingestion into another software system, or formatting the data for display, or looking at the data that's been input or by an end user or by another system and ensuring that it's in the right state, that it looks correct in order for it to be used inside of our application. So mastering the manipulation of strings is a vital skill in Visual Basic. Furthermore, the string data type can hold a lot of information. It's actually, when you compare the buckets and the sizes of the buckets in the computer's memory, the string bucket is a massive bucket if you want to continue that analogy. So efficiently working with strings is another vital skill in Visual Basic. And in this lesson, I'm going to demonstrate several common string manipulations that are made easy by both Visual Basic proper as well as the .NET Framework class libraries and the inherent functionality that it baked into the string data type, the string class. Okay, so you can see that I've already created a new project called Working with Strings, and we're going to do several different things. We're going to work with special characters inside of our literal strings. We're going to format strings for display using the replacement syntax that we've already looked at a couple of times. We're going to look that it has actually more functionality than what we've seen up to this point. We'll look at just basic string manipulation, pulling things out, putting things in, breaking it apart, things like that. And then we'll take a look at working with large strings more efficiently by using a special class called the String Builder. All right, so let's begin by looking at how we work with literal strings and special situations with literal strings. So for example, I might create my string equals my so-called life, and I have a couple of options here. If I want to say this in an ironic way, I could separate so-called using a single quote, but what if I needed to use a double quote? Unfortunately, if I use double quotes, it's not going to look quite right, and I'll get some errors here because we're not able to tell the Visual Basic easily that we just want to use a double quote here inside of our literal string. So to fix this, you can escape double quotes by using double quotes together. So when I pair up double quotes like so, we're saying we want this to be treated as a double quote inside of a literal string. Same thing with this second instance right here. And so we're able to treat the whole thing as a literal string. And if we were to print this now, let's go console.writeLine my string, and we'll go console.readline. It will actually print out correctly for us. And I just hit the F5 key on my keyboard to run it instead of hitting the little run button, the start button on my toolbar. You can see it formats it correctly, my double quote, so-called double quote life. Great. All right, so next up, let's comment that out, and we'll take a look at what if I need to add a new line or a line break in between a literal string. So here I might have my string equals what if I need a new line. All right, and I want to put maybe that new line character right here. How do I do that? Well, we've already seen the little technique that we've used to kind of add two literal strings together using the ampersand character, right? And so what we can do is actually in between the ampersand characters use this special constant called VB new line. All right, and there's a bunch of these little constants that are available for VB. If you type in VB and you look in IntelliSense, some of these have very specific usages that may not make sense here, but I'll show you a couple of these throughout the remainder of this lesson. But for now, we just need something that tells Visual Basic that we want to create a new line right in the middle of our literal string. So let's go ahead and run our application now. And you can see that we were able to break onto a new line, even though it's one literal string here that we've created on line number 6. All right. What if I need to add a tab in the middle, a tab spacing in the middle of my literal string? So what if I need a tab in my line? So the same thing would be true here. I'm going to go ahead and start the process by splitting these two segments into two literal strings and appending them together using the ampersand. I'll add a second ampersand and glue them together with then a VB tab. So another constant from Visual Basic, the VB tab constant, and now when we run the application, you can see that it puts a tab spacing in between the two segments of my literal string. Okay, so that's how you insert these special characters or these special situations into your literal strings. All right, next up, let's talk about the formatting, the special formatting that we did inside of strings using, remember, console.writeLine, and we were able to say, hey, there's this replacement syntax, and I can replace that with something like Bob. So I can do hello, comma, and then the replacement code 0. Whoops, and let's go ahead and just remove that part. So we did that, right? And we could see something like this, right? So what if, let's get rid of that, and let's go back down here. What if I need to do that same sort of replacement code, but inside of a literal string? Instead of using console.writeLine, because you saw that wouldn't work, I can use string.format, and it's identical. We can do the same sort of thing with that. So hello, comma, replacement code 0, Bob, exclamation mark, and let's go ahead and dim this. String equals string.format. There we go. That's the correct incantation. And we get the results that we're looking for. So string.format will allow us to add the little replacement codes, the formatting replacement codes here inside of a literal string. Here I just used another literal string, but we could use a variable or whatever. All right. So that's a very simple case, but let's look at some more interesting cases. So for example, we already looked at an example where we were able to use multiple input parameters. So string equals string.format, and then we were able to do something like the make 0, the model 1, and the maybe even year 2. Of course, this is 0 based, and we will do, so we have a very specific format that we want to print our string to screen. And then we can also then add in the values that we want. Like for example, BMW, 745 Li, and 1995. All right, and let's go ahead and put some of these on separate lines so you can see them. So I'm going to add a line continuation character right after the equal sign. And then I'm going to go ahead and split these off into different lines as well for readability's sake, like so. So this is all one line of code, even though I split it off into multiple lines. And now let's see what we get whenever we run this. And the key notion here is that we're able to insert multiple replacement codes inside of a literal string by just supplying then a list of input parameters after the template that contains the replacement codes. It's zero base, so the first item, the second item, the third item will be replaced in to those replacement areas that have the curly braces and the index. Now we can mix things around. For example, like I could take the 2 and put it here, and take the 0 and put it there. And then I could also use the same replacement code twice inside of the same string, so that I could essentially use that same number 1995 2 times. Of course, this will be nonsensical because the make is not 1995, but you can see at least I'm able to switch around the order. It does not have to be just in the exact same order as inside of the template as we have the items that we're passing in. But this is still element 0, 1, and 2. We're just putting them in different places inside the template and even reusing them multiple times. All right, let's comment all of that out. And now let's take a look at an even more interesting usage of this. So my string, and say that we wanted to format a string for a specific purpose, like we wanted to take the number 2335, and this number, we want to represent it as currency. So in that case, inside of the replacement code, we're going to use the colon and then a special replacement code formatting syntax. And this will represent this as currency. Now, if you're in another country, and for example, if you're in Great Britain, it will represent this based on your operating system's locale feature. So you may have it represented with the British pound sign as opposed to American dollars with the dollar sign. And so it's smart enough to know how it should be represented on screen. In this case, you can see the dollar sign 2335. All right. Here we're going to do the same thing, dim my string as string. Now, you may have noticed here that I was able to do this and not declare a data type. I don't recommend that you do that. It's kind of an advanced topic to explain what happens when you don't do that. I don't want to get into that right now. Let's just go ahead and fix the code. But that was my mistake, but it'll still work, okay? But it has a different connotation and some downsides, so we'll just not do that. All right, next up, let's format this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, but let's format it as a real number with commas and decimal points at the right spots. All right, so I'm going to use this special format code colon capital N. All right, and so now let's run this, and you can see that it makes it into an easily readable number of 1,234,567,890.00. Okay, so that's the N formatting code. And then here, dim my string. What if we needed to represent a number as a percentage? So string.format, and we want to take the number 0.123 and represent that as a percentage. So again, we'll start with the replacement code 0, but I'm going to use colon P this time. And now you can see that it will print out the number as 12.30 or 3% with the percent sign. It also uses the decimal place in the correct spot. So that's how you work with the replacement code and the formatting of a percentage. And then finally, you can create your own custom templates, I guess you can say. Replacement codes using, for example, I want to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I'm going to create a phone number. So I want to use the way that you would represent a phone number in the United States. Which is 3 digits for an area code. So I'm going to use pound, 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 which means just 3 numbers, the first 3 that you have here, and then a space, and then pound, 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 dash, pound, 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 pound. Okay, so that's the format of a phone number. I could even do something like this, phone colon, just to kind of flesh out this example a little bit. All right, so now let's see that in action. Let's run the app. And whoops, didn't do something here. Oh, that's right. All right. I didn't give it the